So in this case, if we want to prove similarity, remember we need to start our proof. Proof in triangle DEF and triangle GFE. Okay, we need to then prove three things. 1, 2, 3, right? Okay, we're going to have to prove, because it's similarity and not congruence, we can only prove either two things. We can either prove angle, 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 or we can prove sides and proportion. Now, in this case, we don't have any sides. We don't have any sides in proportion. So that's not actually going to help us in any way. We're going to have to use angle, angle, angle here. All right, so let us think. Okay, I'm going to number these. I'm going to number that 1. I'm going to name that 2. I'm going to number this 1. I'm going to number that 2. All right, so who can think of anything that we can use here to prove for similarity? Remember, we're going to have to use angle, angle, angle. We don't have any sides in proportion. So let's look of angles. Let's think of angles. What are we thinking in terms of angles, guys?
Ma'am, angle E1 and angle F1 are equal to each other.
Good, they're equal. Give me a reason, my darling.
Is it co-interior? No.
It makes the N or the Z. Yes, absolutely, it is. You're correct. You're correct. That's it, alternate. Excellent. But you're not done. As soon as you tell me alternate angles, what else do we need to do? You must give what? You can't just tell me angles. You must also give me the parallel lines. So you said E1 is equal to F1. Which parallel lines did we use? We said that?
ED and
ED.
FG.
Good. Parallel to
and
FG.
GF, sorry.
GF and ED, same thing. Okay. GF, FG, same thing. All right, good. So that's the first pay. Thank you so much, Mandisa. Let's look for another one, guys. Anybody got anything else? Okay, I'm going to tell you now, guys. Mandisa used the N in that direction. Is there any other way that we can write a Z on the screen? A Z or an N? Do you see it? I see that one there. See that one and that one. Right. That's another N or another Z. So that tells me that E2 is equal to angle F2. And my reason here is also going to be alternate angles. Alternate angles. And I'm going to have to name my parallel lines. So in this case, EG is parallel to DF, right? And we said in any two triangles, if any of the two sides are equal to each other, we automatically know that the last pair of sides is going to be equal to each other. Okay, and the reason we know that is because of the interior angles of a triangle. So I can then say that angle G is equal to angle D. Actually, I need to do that the other way around. Otherwise, my OCD is going to kick in. Angle D is equal to angle G. And my reason for this is because it's the sum of the interior angles of a triangle. All right, if the other two angles are already equal to each other, because both triangles are 180, it automatically stands that the last two sides will be equal to each other. And then I can say, therefore, triangle DEF is similar to triangle GFE. And my reason here needs to be angle, angle, angle. Right, now I want us to use this. Remember, guys, we need to map out which sides are in proportion, right? So if I ask you guys, DE, side DE will be in proportion to which side? To?
GF.
Absolutely, to GF. Well done, my darling. Good. So DE is in proportion to GF, which is also equal to, which other two sides would be in proportion? I would say EF, right? FE and FE, but also it's because they have EF in common, right? EF and FE are the same. So obviously EF over EF must be the same thing. FE over FE, EF over FE must be the same thing. Let's talk about the last pair. I know DF will be in proportion with
GE. GE.
GE. Good. DF will be in proportion with GE. All the way on the other side. Good. In proportion with GE. All right. And this is what we learned about similar triangles in the last lesson that we did on Wednesday. Okay. I hope you guys tried the quiz. How was it? I thought it was really nice. I had fun setting it. Ooh, my nose is just super duper blocked. Okay. I'm sorry, guys. I'm going to be blowing my nose quite a bit today. So sorry in advance. All right. Good afternoon, everybody. Hello, Vanessa. Give me 1 second. I'm just going to mute. Okay. Does Marissa say same, ma'am? Are you saying same, ma'am, to you've also got a congested nose, or same, ma'am, the quiz was super easy and fun? And I'm liking that you found it easy and fun, Michael. Welcome. Let me just stepping on my own things here. All right. Oh, you got the flu. I know. Oh, it sucks. It sucks. At least I get to drink ginger tea, so I don't get sick and things. It's my favorite part because I like this taste of ginger tea. All right, let's get into today's lesson. Today, we're going to be learning about, okay, one more proof, and then we're actually going to be going into quadrilaterals. Okay, so today, we're going to be looking at these two triangles over here, and we're going to prove that they are similar by using, we can't use angle, 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 because we don't have any angles. We're going to have to use sides in proportion. So let's start by mapping out our two triangles. So I'm going to start proof in triangle. All right. And then remember, guys, if I pick a spot to start somewhere, I need to make sure I pick the same spot to start somewhere else. So if I say in triangle A, B, C, right? If I say in triangle A, B, C, and I need to make sure that I map out the other triangle properly. Otherwise, I'm going to have a problem. So if I had to map out the smaller triangle, how would I map it out? What would I say?
PQR.
Absolutely, good. I have to start at the top and go to the left and then go down. Good. So that would be triangle PQR. Right. Again, we need three things. Right. But because we're using sides in proportion, let's use our triangles the way that they've been written out for us. Hello, Bikanyo. Lovely to see you. All right. So we're going to start with the first two. We're going to say AB. AB is in proportion with which side, guys?
PQ.
PQ, absolutely good. So let's go ahead and put those values in. I want us to go AB is in proportion with PQ, which is equal to, I know that AB is equal to 7 over PQ, which is 2,8. I want somebody to put that into their calculator for me and give me an answer, please. What is 7 divided by 2,8?
5/2.
5/2, good. All right, so we're going to get 5/2, which is actually 2,5, but we'll leave it at 5/2. All right, let's go to the next one. 5/2 or 2,5, guys, it doesn't matter. They're both correct, my darlings. All right, then we're going to go BC. BC is in proportion with which side?
QR.
QR. Right, QR. Right. So we're going to get BC over QR, which is equal to, let's go find the value of BC. BC is 9,5 over 3,8. Right, punch that into a calculator and give me an answer, guys. What do we get?
2,5.
Melissa, yep, that's it. Excellent. 2,5 or 5/2. 5/2 and 2,5 are going to give us, actually, let me just do this. 2,5 2,5, because both answers are correct. All right, now we need to do the last two. AC is in proportion to which side? AC is in proportion to?
PR.
PR, good, PR, which is equal to, AC is 8,2 over 3,28, and that should indeed give us 5/2, or as Pena says, 2,5 as well. All right, so do you guys see how important it is for us to map out our triangle properly? Because I can guarantee you, if I had said in triangle ABC, and then over here I decided to go and triangle QRP and triangle QRP, I'm telling you now that AB and QR wasn't going to give us the proportion that we wanted. So it's very, very important that we map our triangles out properly. Now, in this case, because all the ratios are equal to 2,5, I can say, therefore, triangle ABC is similar to triangle PQR. Now, my reason cannot be angle, angle, angle. I don't have angles. So my reason needs to be sides in. Okay, give me a thumbs up if what ma'am has just done is spot on. Thank you, Peño. I see you there. Lovely. Is everybody understanding what's happened here? Balisa, thank you. Good, good, guys. It's just a matter of working with what we have. If we don't have enough angles, then we use sides and proportion. If we don't have enough sides and proportion, we use angle, angle, angle. We just need to work with what we've got. All right, so let's get into today's actual lesson. Today, we're actually going to be talking about quadrilaterals. Now, what is a quadrilateral? Who can tell me what is a quadrilateral? Anybody want to? Good. It's any shape enclosed in 4 sides, and it must be enclosed, hey? Because if you say a 4-sided shape, I could do that. That's a 4-sided shape, but it's not closed. So it needs to be an enclosed shape with 4 sides. 1, 2, 3, 4. Even if it's irregular, as long as it has 4 sides that are enclosed together, it's a quadrilateral. Okay, it could look ugly. It could look like that. As long as there are 4 sides and they're all enclosed, it's a quadrilateral. Okay, we're just going to be looking at specific quadrilaterals because what we're going to try and do today is we're going to try and look at the properties of, specifically, we're going to be focusing on parallelograms because that's part of the CAPS curriculum, but we're going to be looking at all of the different quadrilaterals that we do get, the shapes. So we need to learn these shapes. Okay, there is no way around it. Okay, regardless of what we do today, however far we get today, your homework for today, your homework is to go and learn the properties of quadrilaterals. The properties of quadrilaterals before we even do anything. Because the more you know about quadrilaterals, the easier it is for you to prove things about them. It's easier for you to use them. So we must know them in advance. All right, so that is your homework. Before we even get to the end of today's lesson, you already have homework. Okay, we're going to be focusing today specifically on quadrilaterals. So I'm going to give you guys a chance to take a screenshot, not quadrilaterals, sorry, parallelograms, sorry, of this thing that I've got on the screen now tells us of the properties that we need in order to prove that anything is a quadrilateral. Why do I keep saying quadrilateral? Parallelogram. Oh my goodness, Teacher Coco. Okay, we're going to be focusing on the proof of a parallelogram, not a quadrilateral, a parallelogram. Okay, so you will see in this first picture over here, they have given you all the proofs on the screen. I will tell you now, they've given you all the things that we need to know about a parallelogram. And if you're on your computer and you want to take a screenshot, look for a button that says PRTSC. Click on that and your calculator and your computer will do the rest for you. Yes, I'm giving you online work. See, don't be lazy. See, don't be lazy. Don't be lazy. All right, so we'll see that there are two different things that they're telling us here. In this first drawing over here, they're giving us the properties of a parallelogram. Right, so you'll see here, if ABCD is a parallelogram, they're already telling us that it's a parallelogram. You may assume the following properties. Then we know, they tell us that AD will be parallel to BC, AB will be parallel to DC, AD and BC will be equal, AB and DC will be equal. AE, that over there and that over there will be equal. So AE is equal to EC, and similarly, BE is equal to ED. So all of these things are true if we are given a quadrilateral, a parallelogram. Guys, okay, let's just get this out of the way, because clearly today my English airtime is at 50 cents. Okay, whenever I say quadrilateral, I actually mean parallelogram. Can we just be okay with ma'am saying quadrilateral for now? Because clearly it's been a long day, guys. So, okay, so just stick with me here. If I say quadrilateral, I mean parallelogram. Okay, I'm gonna try my best not to, but you get what I'm saying. All right. Okay, so here's what we need to note, grade 10s. If any question that we get already tell us, if the question says something, something, something is a parallelogram, then we have a green light to use all of these things. Okay, but if a question that we're working on says, prove that a quadrilateral is a parallelogram, we can't then use these things. We need to prove one of these things. We need to either prove that AD is parallel to BC, to DC, or that AB is parallel to DC, or we need to prove that AD is equal to BC or AB is equal to DC. We need to prove one of these things in order to say, therefore, ABCD is a parallelogram. Okay, so we need to read instruction very carefully. If they already tell us that it is a parallelogram, away, we can go ahead and use all the properties. But if they don't tell us this, if they don't explicitly say that it's a parallelogram, we are going to have to prove that it's a parallelogram if we want to use the properties of a parallelogram. All right, let's look at what the CAPS document has to say about this. There are exactly 3 proofs that we're going to be looking at today. Okay, well, actually it's 2 proofs, but the other one is very helpful as well, right? So this is what the government wants from grade 10 in terms of quadrilaterals. It says here, we could define a parallelogram, because that's what we're focusing on, a parallelogram as a quadrilateral with 2 pairs of opposite sides parallel. Okay, now I want us to note something. Do you see, guys, that ma'am has drawn over here? I've drawn a parallelogram, right? I've drawn a parallelogram, but because the definition says, let me do this rather. Because the definition says 2 opposite sides must be parallel, if I decide to draw a rectangle, do I still have opposite sides parallel? Yes or no? Do I have opposite sides parallel? Yes, Michael, I do. Right, because it's a rectangle. So what this actually tells us is that a rectangle is also a parallelogram. It's just a specific kind of parallelogram. Can you guys think of any other shape that also has 2 sides parallel like this on each side? Both pairs of sides parallel. Yes, Sally, absolutely. You're 100% correct. A square. Right, a square. Right, a square, which means that a square is also a parallelogram. A square is a palm. Ooh, not a kite. A kite is not gonna work. Okay. Yes, Sia. Yes. Okay. Somebody just said cat. Cat said a rhombus. That is correct. A rhombus would also be. Michael, unfortunately, because of the nature of a kite, we need parallel lines. And because this side is shorter than this side and the angles are different, it's not going to give us parallel. And if we do get a kite that is parallel on each side, it's most likely a rhombus. So a rhombus is a parallelogram. So when ma'am says we're dealing with parallelograms, I'm not just talking about this one, this rectangle that slants a little bit. It could be a rhombus. It could be a rectangle. It could be a square. All of those things are parallelograms, but we need to be very careful, guys. Okay. If I say a rectangle is a parallelogram, does that mean that a parallelogram is a rectangle? Yes or no? This is a true statement. We've just looked at it, right? I can say a rectangle is a parallelogram, but can I say that a parallelogram is a rectangle?
Yes, you can.
Sally says no. Somebody in the chat says yes. Mandisa, was that you?
If it's correct, it was me.
Okay, if it's correct, it was me. Unfortunately not, my darling, it's not. Okay, and the reason why is because what is the defining quality of a rectangle? What do we know about the corners of a rectangle specifically? What do you know about the angle here at a corner?
90 degrees.
Absolutely. The angle must be 90 degrees, right? Whereas in a parallelogram, they don't have to be 90 degrees. So a rectangle is a parallelogram because the opposite angles, so this angle and that angle are equal, much like in a parallelogram, they'd be equal. But a parallelogram can't be a rectangle because in a rectangle specifically, I need there to be a 90-degree angle. Okay, am I making sense? Give me a thumbs up if you understand what ma'am is saying. You with me? Cool. Let me give you another statement and I want you guys to think about it. Okay. A square is a rectangle. Now I made it look like one word, a rectangle. It's not. A square is a rectangle. A rectangle is a square. Which one of these is false? Number one or number two? One of them is true and the other one is false. Let's talk about it. Sally says number two is false. Okay. Michael also says number two is false. Do you guys want to explain to me why? Why is it false? Right. Remember, the defining quality of a rectangle is that they have 90-degree angles. But if I draw a square also has 90-degree angles in the corner, right? It also has 90-degree angles. But what is the defining quality of a square? Who can tell me?
All sides must be equal.
100%. Wow, excellent. So, can a rectangle be a square? No.
No.
A square can be a rectangle, true, but a rectangle cannot be a square. So, guys, are you seeing how we are going to define parallelograms inside of parallelograms? We need to be very specific about exactly what it is that we're doing. So, when we're proving a parallelogram, all we have to do is prove that opposite sides are parallel. That's all. But When we prove the parallelograms inside the parallelograms, there's going to be a little bit more work to be done, right? So if they say prove that something is a parallelogram, we only have one job to do. We just need to prove that the opposite sides are parallel. But if they say prove that something is a square, ooh, now we've got a little bit more work to do. First, we have to prove that the opposite sides are parallel. Then we have to prove that the opposite angles are 90 degrees. Then we have to prove that all sides are equal. Okay, otherwise you're not describing a square, you're describing a parallelogram or you're describing a rectangle. So it's going to take a little bit more digging for us to get there. All right, is everybody okay with this? I don't want to leave anybody behind. It's a bit of a ma'am what kind of situation, but we do need to get it right, guys. Okay, oh, just deleted our whole life there. Okay, let me just use the eraser, it's fine. Okay, so it's very important, guys, that we understand the difference between each of these. Okay, so there are three things that the Department of Education wants you guys to be able to prove. Okay, here is theorem 1, here is theorem 2, and here is theorem 3. We're going to deal with these in a little bit more detail. So I want you guys to follow along with me. I want you guys to write down theorem 1. Theorem 1 says the opposite sides and angles of a parallelogram are equal. So these are the three things, or the two things that they want you to prove. Number 1, they want you to prove that opposite sides of a parallelogram are equal. That's what we're going to prove. They also want you to prove that opposite angles of a parallelogram are equal. So we're going to take those two things and we're going to prove them in one theorem. Okay, and the way we can do that is exactly what they asked us to do. They said we must prove that the opposite sides of a parallelogram are equal. So we are required to prove that in this parallelogram ABCD, we need to prove that AB is equal to CD, and we need to prove that AD is equal to BC, and we need to prove that angle A is equal to angle C, and that angle B is equal to angle D. All right, now, at the moment, all we're doing is we're just looking at a parallelogram. In fact, we don't know that it's a parallelogram because we're trying to prove that the opposite sides of this thing are a parallelogram, or of a parallelogram are equal. So we know what we're required to prove. First thing we're going to do, number 1, is we're going to construct some lines. Okay, we're going to have to construct some things, get okay with writing certain things down, make sure that we're understanding where we're coming from. Okay. So first thing we're going to do is we're going to, excuse me. Sorry, I just need to answer this. Sorry, I just need to help somebody who's stuck quickly in the chat. Give me a second, guys. Okay, cool. Okay, so first thing we're going to do is we're going to construct some things. Okay, we're going to construct a couple of lines, right? So, because it's necessary for us to do that. So we're going to say, okay, we're going to say construct line AC, construct line AC and BD. Okay, that's the first thing we're going to do. We're going to construct a line from A all the way to C. Yeah. Okay, hold on. Oof, goodness. All right, and then we're going to construct a line from B to D. BD. All right. Okay, lovely, lovely, lovely. That's the first step. All right. Then we're going to pick two triangles. Okay. And we're going to have to use these two triangles to prove congruence. Right. So I'm going to choose in triangle ABD. I think ABD would work. Let's see. Triangle ABD and triangle C. Where did I start? I started at A and I went to B and I went to D. Sorry, proof. I forgot to say proof, guys. Proof. In triangle ABD and triangle. Let's see what the other triangle will look like. If I start at A and I go past the short side and through the middle, that's going to be, what's the other triangle then going to be, guys? CDB, correct. Okay, because we went from A past the short side, we need to start in the corner at C and go past the short side. So we need to go C, D, B, right? And triangle C. We can label it. You can label it E. It won't make a difference. Okay, it's just called a bisector. It's not perpendicular or anything, but you can label it E. Okay, CDB. All right. Now, because we're proving congruence, how many reasons do I need? I'm going to make this 1, 2, 2, 2, 1, 2. I need to prove congruent congruent triangles. How many reasons am I going to have to come up with, guys? How many reasons? 3, absolutely. It's always 3. We always need 3. 1, 2, 3. Okay. Now, here's the nice thing for us. In this write-up that we've got up top here, right? It says here that we're proving that the opposite sides and angles of a parallelogram, right? And in this definition that we've been given over here, it says we could define a parallelogram as a quadrilateral with 2 pairs of opposite sides being parallel. So what that tells me is, in my drawing, AD is already parallel to BC, and AB is parallel to DC, because we're proving the other properties of a parallelogram, and we've already been told that a parallelogram has opposite sides parallel. Okay, whenever we see parallel lines, what should we be thinking, guys? What are we thinking?
Fun angles.
Fun angles, yay, whoop, whoop. Good, we're thinking fun angles. All right, let's take this idea and I want you guys to help me prove congruence, please. Sorry. I know I look like a drug addict, but it's vapor, it's Vicks. Good, Michael says he sees an N, good. Where do we see the N? I see the N like that, there. Because remember, guys, we need to think about where our triangles are. Okay, we need to think about where our triangles are. So that side and that side. So that tells us that B2 is equal to D2. What's our reason, peeps?
Alternate angles.
Good, alternate angles. And what else do we still have to provide?
Parallel
lines.
Good, AD is parallel to BC. Good, can't forget that. Good, that's 1 N. What else do we see, guys?
Let me see another N.
Okay, good. From where? Where can I start with that N? It's going up, down.
D, yeah.
From A to B through the middle, right? That way.
Yes.
Is that it?
Yes,
Okay,
ma'am.
good. What are we gonna get?
Angle B1 and angle D2. D1,
Remember the
sorry.
inside. So D1.
One.
Good. We get angle B1 is equal to angle D1. What's my reason?
Alternate angles.
Good. Alt angles. Give me my parallel lines, please.
Is it AB is parallel to DC?
Absolutely. AB is parallel to DC. I need one more reason. Okay. Remember, guys, what are we trying to prove? Congruence or similarity? We're proving congruence. So I've already got two angles. Can I find another angle? Am I allowed to find another angle?
No.
No, I can't. I'm not allowed to. Because if I do, then I've proven similarity and not congruence. So what do I need to look for?
A side.
A side. Good. We're looking for a side. Who's found a side for me? I'll give you guys a hint. It's in the two triangles, the way we've mapped them out. ABD and CDB. Have a look.
Ma'am?
Yes.
Is it? No, never mind.
Let me highlight it for you guys.
Is it BD a common? BA?
Yes, absolutely. BD is common. That's it. Do we see how they show both share BD? Yes, both triangles have BD in them. So BD is common. BD is common. And we don't actually need a reason for that one, but you know that it's a side. Now that we've done that, we can say, therefore, triangle ABD is congruent to triangle CDB. And the lovely thing about that is that we know that if these two triangles are exactly the same, right? If I know that this triangle is the same as that triangle, that tells me that they are identical. Right. What was my reason again? Let's look at our reason. We had an angle, and we had a common side. Okay, in the other one, we had an angle, B1, we had D2, and we had a common side. What do we call that? What's our reason?
Angle, side. Huh? Please. Angle, side, angle.
Angle, side, angle. The side is in between them. So this is ASA. It's angle, side, angle. Good. Now that we have proven that these two triangles are congruent, which means that they are exactly the same, then my two triangles tell me so much. That tells me that side AB must be equal to side. Therefore, AB is equal to what side?
DC.
DC or CD. Do you see that? Just like this
Yes.
says. See that AB is equal to CD, right? And we can say it's because of congruent triangles, right? We've proven, it's been proved above, they are congruent sides. Okay, then we can also say, because of this, we can also say that BD and BD is common. We know that BD is common. Let's look for that last one. That means AD, side AD is equal to which side? AD
BC.
is equal to good. BC. And again, because of congruent sides. Good, we know that AD is equal to CD. We can also then look at each of these. I'm going to quickly just remove some of the stuff. I'll put them back in there. This is CDB, and that was ABD, right? From that, we can then also say that angle A is equal to which angle? Angle A is equal to angle?
C.
Yes, that's it, Keratilo. That's it, Michael Goodball. It says equal to angle C. Do you see, guys, ma'am wasn't joking when she said you need to know how to map these things out properly, hey? This means that our angles are congruent angles. Okay, which just congruent means equal. Okay. Excuse me, guys. Whew. What else? Somebody give me something else. What do we know?
Angle D is
According
equal
to
to
our
angle B.
Angle? D must equal angle B. Absolutely good. We know that angle B must equal angle D and angle C must equal. Ivo, why did ma'am write angle C? Why did I write ABC instead of ABD? Sorry. Angle B must equal angle D, which is true. Angle B is equal to angle D. Even if I do the next two, it's going to tell me the exact same story. The next two, D is going to say D is equal to B, and we've just said that D is equal to B. All right, so give me a thumbs up. Do we see how it works? Sorry, it was me, Michael. I wrote them down wrong. Sorry, guys. Right. Thumbs up, guys. Is everybody okay? Tandulutu looks a little confused. What's up, What's up, Tandulutu? Okay, it's all about using what we've been given. Okay, we are using the definition of a parallelogram, and then we're using, see, ma'am doesn't make you guys do nothing, it's things for nothing. The whole reason we went through congruence and similarity is because I knew we were gonna have to use it. So now that we know how to map out our triangles, they kind of just pick off each other. Oh, okay. All right. Okay. Let's talk about the diagonals of a parallelogram bisect each other. Now, this word is very, very, very important. Okay. The word bisect is very important. Who can tell me, who knows, what does bisect mean? Correct, Tandoloitu, absolutely. The word bisect means cut in half. Okay, so let's just think about this. If I have a line, okay, I'm gonna call this line AB, and I construct a bisector C. This then tells me what? If C is a bisector, what does that actually tell us about line AB?
Ma'am, it doesn't mean that line AB has been cut in half.
It has, yes. Good. So we know that this is the halfway point, right? What does it tell us? Let's think about this. If the distance from AB, from A to B, was 20 meters, what is the distance from A to C going to be?
10.
Ma'am, it's going to be from 10.
10 meters, right? And what is the difference from C to B going to be?
10 again.
It's also going to be 10. What do we notice about these two things?
When added, they give you 20.
They give us 20, but that also means that they are both what? I'm looking
Equal
for
to
a
each other.
specific. Yes, absolutely. That means that they are equal to each other. Okay, does everybody understand what ma'am's saying? If this thing cuts it in half, and this is 10 meters, and this is 10 meters, what this actually tells me, what this is actually telling me is that AC is equal to CB. Is everyone with ma'am here? You guys understand me? If we've got a bisector and it cuts the thing into two equal parts, that means that those two parts are then equal to each other. All right, and that's very important because when we look at the idea of things bisecting, when we want to prove that something bisects, what we're going to have to prove is that the two sides are equal to each other. Now, just out of curiosity, can we use a similarity proof or a congruence proof for sides being equal? Is it going to be congruence or similarity?
Ma'am, congruency.
Of course, it must be congruence. Okay, similarity isn't going to tell us anything about the sides. It's only going to tell us something about the angles. It's going to tell us the angles are equal. It's not going to tell us that the sides are equal. So we need to set up our parallelogram so that we prove that the sides are equal, which means we need to then look at congruence. Okay. So again, we're going to draw our parallelogram A, B, C, D. Let me name it. Okay, parallelogram A, B, C, D. Okay, and then it's going to say required to prove. Do you see what we're proving here? We're proving that AE is equal to EC and that BE is equal to ED. So we're then going to have to construct. We don't have an E as yet. So I need to first construct. What are the two lines we're going to construct, guys?
And you're gonna construct AC and BD.
AC and BD, good. Construct AC and BD. That's what we're going to do. Let's start there. Okay, and again, guys, MEMS, like artist skills, they are 0. Okay. All right, we're going to construct line AC and BD. All right, so now, Kat, we absolutely can name the middle E. I hope it was Kat who asked, I can't remember. Then we're going to name the middle E. Right. Now, I want us to note something, guys. That the proof, what it says we're required to prove over here, says that we must prove that AE, that part, is equal to EC, that part, and we must prove that BE is equal to ED. Now, if we had to prove that these two sides are equal to each other, can I use the big triangle? Yes, correct. I hadn't even finished, but Michael's already onto something. We know that it's a parallelogram, so this side is parallel to this side, and that side is parallel to that side. Right. Can I use the big triangles like we did in the equation, I mean, in the proof before, the one above? Can I use those big triangles? No, they're not going to help me because the big triangles are going to give me this whole side. They're just going to tell me that BD is common. And that doesn't help me. That's not going to help me in any way. Right? It's not going to help me. So instead of using the big triangles, which triangles do you guys think we can use here?
EC. ECE.
Can you use the small ones? Map them out for me. Yes, the small ones. A, B, what?
ABC.
Yes, absolutely. We can use triangle ABE. And which other one?
Triangle CDE.
Good. We started here, past that side, and all the way to E. Beautifully said, my darling. Good work. All right. So we're going to say proof. In triangle ABE and triangle CDE. How many things do I need to prove congruence? I need 3. 1,
3.
2, 3. Okay, good. So where can we start in these? Now, remember, guys, in theorem 1, what did we prove about a parallelogram? We said that AB is what? Is equal to?
CD.
CD. Good. We've proved it up here. We've already proved that the big sides are equal to each other. So we can say, we can start by saying AB is equal to CD. Right? We've proved it. It's a property of a parallelogram. So we can say AB is equal to CD. Properties of a palm. Good. Now, that's the only thing that can help us with. It doesn't help us with anything else because AD is equal to BC talks about those big sides. Those big sides are not part of my triangle. And the angles themselves says A, the whole of A, and that part is not part of my triangles that I'm using. So the only information we were able to use up top here is just that AB is equal to CD. That's all. The rest, we're going to have to use what Michael said. We need to use fun angles. Right, so find them for me, guys. Find me the fun angles in the 2 triangles that we're using.
Ma'am, I found one.
Tell me.
Ma'am, can you just put the 1s and the 2s there for me? So,
Oh, yes.
thingy, please.
Sorry. 2, 1, 2, 1,
Okay.
2, 1, 2. All right, go for it.
The first one would be angle A1 is equal to angle C1 because they're alternate
Good.
angles.
Absolutely good. We can map out our N like that. There and there. Good. So we can say angle A1 is equal to angle C1. And you're not done. Don't cheat me, my darling. What are my parallel lines?
AB and CD.
Good. AB is parallel to CD. Okay. We need to do it. All right. Beautiful stuff. Good. What else, guys?
B2 is parallel to D2. I mean,
B2,
equal, sorry.
okay, B2 is equal to D2.
D2, yeah. AB is parallel to CD.
AB, CD, absolutely. And then we'll get B2 is equal to D2. And the reason for that, again, is alt angles. Beautiful. AB is parallel to CD. Excellent. Good. Now that we have all three, right? I'm going to get, therefore, triangle ABE is congruent to triangle CDE. What's my reason here, guys? Remember what we said. We said that, oh, look at now what ma'am's done. Okay, we said that side AB is equal to side CD. We said that angle A1 is equal to C1. We said angle B2 is equal to C2. Do we see it? Does anybody see it? What's our reason?
Side angle.
Yes, good. It's two angles with a side in between. So this becomes angle side angle. Nicely done. All right. But that then tells us some very interesting things, doesn't it? Let's start mapping out our sides because remember, guys, this is congruence and not similarity. We're not going to say that the sides are in proportion. We're going to say that they're equal to each other, right? We already know AB is equal to CD, which is lovely, right? AB is equal to CD. We proved it above. What else do we know? Let's look at how it's mapped out for us, guys. What else do we know? That BE is equal to
DE.
DE. Good. We know that BE is equal to DE. And what else do we know?
AE is equal to CE.
Beautiful. Good. AE is equal to CE. And because we've proven it, that's what we were required to prove. Do you see how we proved it there? Therefore, that means that E is a bisector. Because these two are equal, because AE is equal to EC, and because BE is equal to ED, that means that that side or that middle part right there, E, cut both of those lines in half, which means it is a bisector. Okay. It's a bisector. It's cut each of them in half because they're equal to each other on each side. And therefore, the diagonals of a parallelogram, we just call it a palm, bisect each other. All right. Okay, unfortunately for us guys, these proofs are something that we're going to have to learn because they're going to ask you at least one of them in a test or exam. Okay, mainly it comes at the November exam. They ask you one of these, so please make sure you know them. Okay, I'm just going to blow my nose 1 second. All right, okay, let's jump into theorem 3. It does actually remind me of Parmesan cheese as well. Yeah, me too. Okay, maybe I should say, instead of saying parallelogram, maybe I should say Parmesan. It will help me to remember not to say quadrilateral. Okay. Okay, let's look at theorem 3. It says, if two opposite sides of a quadrilateral are equal and parallel, then the quadrilateral is a parallelogram. So how do we prove that something is a parallelogram is what we're getting at next. Okay, so that's something that we're also going to have to learn how to do. Right, it's very important that we know how to do it. Oh, excuse me, guys, my nose is just... Okay, so in this particular one, we're required to prove that ABCD is a parallelogram. ABCD is a parallelogram. Now, obviously, we know that we're going to have to construct some things, right? Okay, I'm going to construct only one line this time. I only need one line for this one. No, we're not going to sleep. No, Sia. Okay, I'm only going to construct the line BAC. That's all. Okay, I'm just gonna... Okay, let's start there. We're gonna say construct AC. All right, then let's start proof. Okay, anybody want to start us off? What are we proving for? Congruence or similarity?
Ma'am, it's a congruency.
Absolutely, it's congruence. Beautiful. Good. So give me two triangles, guys. Let's go. Proof in?
ABC and
Good. In triangle ABC and?
ACD.
Remember where you started. my
Oh,
darling.
it's
Be very
ADC.
careful. Okay, so if you
ADC.
started at A and you went to B, that means you started at a big corner and you went past the short side. So on the other side, you need to start at a big corner. So where's the big corner going to be, guys? Sorry, my laptop is dying. Okay. Give me 1 second before my laptop dies. There we go. All right, good. If I start at a corner, it's a big corner, and I go past a short side and then past a long side and then through the middle. I started at that corner. Which other corner do I need to start at? I can't start there. It's not the same corner. Which corner is it? Yes, Sally is correct. It's going to be at C. And then which way do I need to go? From C, I need to go D. Good. And then I need to go to D and then to A. Remember, guys, it's important that we map them out in the correct way. Otherwise, we're not going to be doing the right things. And triangle CDA. Okay. We need to start practicing these, guys. They're very, very important. Okay, cool. We already know some things. All right, we already know some things. Okay, we know that this is parallel to that. We also know that this is parallel to that. We also know from proving it above that this side and this side are equal. Okay, let's start our proof. 1, 2, 3, and we've got 1 minute, so we've got to run. 1, 2, 3. Quickly, guys, what do we get?
The first one
angles,
would
good.
be angle A1 and angle A. Oh, angle A2 and angle CAA2 are equal.
Yeah, A2 and C2 are equal. Good. A2 is equal to C2. What's our reason?
Alternate
angles.
angles, and AD is parallel to BC.
Good, is parallel to BC. What else do we see, guys?
Ma'am,
What else is
angle A1 is parallel to, no, it's equal to C1,
good?
alternative
A1 and
angles.
C1. Good. A1 and C1 is equal. Again, alternate angles. Now, remember, it's congruence we're proving. Good, Cat caught it. Good. My parallel lines here will be AB is congruent to CD. All right, and then Cat caught it. AC is a common side. Okay. Therefore, triangle ABC is congruent to triangle CDA. I'm doing the exact same thing. CDA. What is our reason this time, guys?
Angle, side angle.
It is angle, side, angle. Well done. Angle, side, angle. All right. Now it says here that if two opposite sides of a quadrilateral are equal and parallel, then the quadrilateral is a parallelogram. Now we've proven that, or we've seen that because these are equal, all the congruent sides will be equal. That means that AB is equal to what?
CD.
Absolutely, CD. Right. That also tells us that BC is equal to
DA.
A. Right. And if they're equal to each other, then that also means that they are parallel to each other. Oh, sorry. If we can prove that all sides are equal, the angles are equal. Phew, okay. It's because we're out of time that ma'am is now blabbering on. I've forgotten where my train of thought was going. Okay. So if we can prove that these two sides are equal and those two sides are equal, that automatically means that they are parallel. Okay, therefore, side AB is parallel to CD. That's where I was going with that. Okay,